Do you see how the action potential comes up for air at each of the breaks in the myelin and gets another boost? This jumping of the action potential from one node to another down a myelinated axon is known as saltatory conduction. The notion of saltatory conduction is sometimes difficult for students to conceptualize. The action potential jumps from one node to another, but it's not like a particle that instantaneously hops from node to node. Instead, because the myelin greatly increases the length constant in the internode region, the action potential gets spread out in space, enough to make it to the next node of Ranvier, where the signal can be regenerated. This process repeats in a chain reaction fashion, just as it does in an unmyelinated axon. But in the myelinated axon, we can cover distance much more quickly, because we're relying on the fast transmission of current down the insulated axon for large spans, and only relying on the comparatively slow mechanism of action potential generation when we need it. This marvelous feat of engineering by nature is what allows humans and other vertebrates to have relatively thin axons conduct action potentials very rapidly over long distances. Adding myelin to the surface is far more space efficient than having larger diameter axons, while still allowing the signals to travel fast. Let's put together everything we've learned about myelin and have a race versus an unmyelinated axon.